How's it going, everyone? Welcome. Olier Gonzalez here. And in this video, I want to explore is the model pattern, particularly starting from the closures, and how do we get here to understand now what the model pattern is, and some of these concepts that allow to describe is the nature of affair in our industry. So, for example, is why do we have React, and what are the intrinsic mechanisms that React allows us to do, what it offers, what is its capabilities. And to do so, we need to understand is now how JavaScript works, not only in terms of things that are around JavaScript, like the people around that, so who made that, who owns the legal trademarks, why the name of JavaScript, and the reasons to have that specific name. And now what are the people that oversee the spec, the TC39 group, what they do, what is their main role to guarantee that specific features now are added to the spec by passing through a series of trails, right, or phases. Any of this proposal of for any of these proposal or champions, right? And also understand that because the web is where the JavaScript emerges, despite you can run JavaScript in any other environments, the only reality that matters is the web. Okay? And there are some exceptions to that rules that do legacy reasons. You can take a look at the appendix B in there. So also is that as you develop applications, and because the nature of software, particularly in JavaScript, is dynamic, it evolves over time. A lot of the time, we need to find ways to use this new syntax, or to provide now fallbacks for these new tools that we have in our language, right? So this is where now polyfills kicks in. And also I have a huge overview of the environments we can run now JavaScript. So for example, if the console is or the from the browser, the console log from the browser, that this, despite that it might look like a JavaScript runtime, is not a strict spec compliant JavaScript. So JavaScript friendly environments. And you can take a look at that, at how now, for example, is it hosts variables here, or it now analyze the user strict as well, which is a way of how now we can, as developers, write code that have better chance for optimizing and running our code, right? So the user strict is a set of rules that is enforced to us as developers to let the JavaScript engine to have a better chance of optimizing and running our code. Okay, so because we also need to understand is what the JavaScript engine is doing and how it analyzes the code, pretty much like a compiler language rather than an interpreted one. And because now the concerns around JavaScript, it is scripting language, is to be a language that in its nature it analyzed one statement after the another. The reality is that this is not true, and because the concern, or at least not true in 2025, but the concerns about that back in 2016, 2013 was real, and there now were efforts to develop a subset of the JavaScript to see how powerful is the language to run, for example, heavy applications like games. So the ASM.js was a project that actually poured an Unreal game engines into the web. This code or this language was not meant to be authored by JavaScript developers, but just show that the web platform with JavaScript is powerful enough to run this game. And then we look, or I look, in my case, at a couple of years later, a group of Mozilla engineers, they now push forward this idea by saying, hey, let's go to skip the parsing phase, have a mirror representation of the language, so we can now run that in a particular environment called web, with the WebAssembly or WASP, right? So now WASP become this universal portable target. So no matter which application you have in any of this programming language, you can now target that to WebAssembly, and whenever you run a WebAssembly runtimes, you can now execute that application there. So that was quite interesting in terms of understanding is the JavaScript in itself and anything that is around it. And then we dive into the things that are more technical. So for example, how JavaScript sees a program. What is a program? What allows a program to do, to describe, is the state of an application. What are the states that we can describe in applications based on the type of values, whether it's a primitive or an object. We have several of these primitives, and each one of them, some of them follow some spec. So for example, in the case of numbers, that follow is the IEEE 7054, that describe is the representation of this number and how they're going to store in memory, and also the limitations. And the other is the string, and how now this use right now is the UTF-16 as a way to represent is the multilingual or something known as the basic blend, aka all the possible characters across the world and cultures, right? And anything that go beyond this abstract plane, or that they go beyond the basic plane, is known as the astral plane, right? Here you have now emojis, combination of emojis, and other things. So we also look at other type of values like booleans, symbols, kind of emptiness, like undefined and nulls, and also objects, and how now objects do the nature of allowed to describe is the key and the value, pretty much like a two-column table, right? It also allows to represent is other type of values, so for example, sequence of values or collections of them, like an array, or functions to describe now functionalities. And as we look at the functions and how the functions works and how you can define some functions, whether it is by declaring that function or assign that function as a value to a variable, all right? So all of this now allows to unlock is the different or a different programming pattern known as the functional paradigm. So when computation is needed, functional programming is or has been shown that is a very good approach. But when you rely on cooperations among your programs, right, how they need to cooperate, object-oriented programming is the way to go, at least at 2025. Okay, so also I look at now how you can play with these values, which is how you can now assign, how you can compare these values. What happens when that comparison is among the same type or different types, or when that comparison, or when you want to coerce or to transform from one type to another, and what is the expected output out of that. And also how you can organize your programs, whether it is by functions or a class or as a model. And then looking at the more in-depth uh, tools right now. So for example, like iterations. Why do we have iterations? What is an iterator? What is an iterable? What is the role of them? How you can use them? And what is the anatomy of the functions? What a closure is, what the this is, and the object-oriented programming as well. So with the what is the anatomy of the object with the prototype change, right? As a way to allow an object is a mechanism for figuring out figuring out if a property exists along a series of objects that are cooperating together or that are changed together, right? So something that in this book they don't mention, but I do think this is quite relevant and important. That is, hey, let's go into now is shift our attentions to the async nature of the language and how, for example, we deal with that back in 2000 with the callbacks. Why we have now callbacks. What is a callback? Which is you're passing now a set of instructions to be executed at some point in time. So because this execution needs to also or involve is coordination, right, and orderly, it becomes quite a nightmare to actually handle that in pure code, right? Especially when you now have to deal with time, when you have to wait for the data. This is why now thunks, programming concept from the distributed era in the 60s, well, it showed now the possibility to hold now a functionality as identifier, as a variables, and when we need that, we can now call that function and pass the functionality or the callback that is going to be called, right? Or that we want to extract that particular data as well. So the whole point of this is to understand that with thunk, that now allows us is to decouple is the timed as part of the equation of coordination, right? Which is good, something that now is heavily relying on libraries like Redux, Redux Redux toolkits, okay? But now, as the industry emerged or as the industry evolved and come up with all of these different tools, for example, substance or recoil, right? They now figuring out more convenient ways to handle is this these eventual values, right? And how you can update your state. Again, I know this might quite abstract, okay? But the point is that now that we don't need to take, now we don't care about the time, all right? We just only care that that data will be available at some points. So this now enters into the realm of the functional programming. And this is why, for example, we have promise, which is now our monads. And I don't want to dive in too much into that. But the thing here is that now promise actually guarantee ourselves to only when that value is available, this is the set of instruction that I want you to do, right? And I can is change computations along the way. And also is process is several of those promises, right, or eventual values. So that's great, that's good, because I also again, that's part of the dive into these core level principles or tools. So we have now generators that give us now the ability to actually is getting into a function execution and using a specific keyword, the yield, to hold the execution of that program and then resume at some point in future. So with this, now allow us is to write code that look like synchronous while performing asynchronous task using now the async and await syntax. And also there is another pattern for handling now series of eventual values. So not only called observables, but also is another pattern known as the CSP, concurring communication communication sequential protocol. I don't think that that's the name. Let me actually double check that. So CSP, it is communication sequence process. I do think is this, which is heavily used on language like Go, for example, right? Communicating sequential process. So this go beyond the scope of today's video. It is a member of the family of mathematical theory of concurrency. That's interesting. That's interesting. It is a member of the family of mathematical theory of concurrency, known as process algebra or process calculus, based on message passaging via channels. This is why we also need to look at this at some point in future, because this is the kind of problem that we as programmers are going to deal with, right? Is this series of eventual values that needs to happen at some point in the future. That's what concurrency means, is that that's what concurrency means. Unlike parallelism, which is our series of values that happen at the same time, all right? So all of these tasks happen at the same time. Concurrency is now activity or tasks that happen across at an X amount of time, all right? So why this is important, right? Because as you now holding services, your web application that needs to communicate with, for example, if you have a bank account, all right, you are now JP Morgan, right? So if you have now all of these systems and you're providing now your service with banking services, so for example, you have now is the, how do you call it, banks so they give it to you as an account so you can have access through their web applications, all right? So let's say you want to now query your movement, all right? So now they need to actually communicate to a particular table, all right? Let's say that is the users, and then another table. This is not what actually truly happens, because they have some things that are way much more optimized to do so. But for basic examples, all right, when you get into the app and you want to know your last 5-day movement, all right, so let's say that they look up for the user on the user table, and then on the transactions, okay? These two databases, now they might live in different servers, as a matter of harness the full power of those CPUs, and also for management wise. So if those servers live separate, right? So the application need to talk first to one, wait for the data to come, and then once that data is there, now query that second service. So all of this is because just to show you some relevant information, because we are dealing with this piece of information, and that we need to wait for that arrival and actually guarantee that it follows certain principles, okay? That is atomic, that is consistent, that is isolated and durable. Then, well, we need to also wait for the second data to be arrived. So the more data that you need to do that, or the more data that you need to query across different servers, the more time you need to wait, all right, and the more coordinations it relies on. So you can think of this like pretty straightforward. When you now purchase, let's say, items from Christmas, for example, right now we are in Christmas Eve, close to Christmas Eve, and well, we just purchased, let's say, our tree, Christmas tree, and some poultry, let's say rough beef, and some toys for your kids, if you have kids or not, doesn't matter. So all of these purchases, right, they're gonna arrive at some point in future, and you have to coordinate that for yourself. Okay, you have to be present at the moment when those packages get in, or you can just wait for those packages to arrive and then collect all of them at once. So this is quite similar of what this processing or this coordination means here. And again, that go beyond the scope of today's video. I just want to point that out because what is relevant here is that as we explore the nature of the JavaScript, well, there is a social aspect as well as a technical one, okay? And when I look now at particularly behaviors of the language, specifically with functions, is by understanding now how the scope and closures works, right? So here's when we actually get into this and understand that working with variables is one of the most important things that you're gonna do in any programming language, okay? Because it allows you to now hold a specific state of the application that represents something, okay? And then because JavaScript now behaves much like a compiler language when analyze the code rather than an interpreted based on how it analyzes the syntax errors, early errors, and in hosting, all right? We also look at what this lexical means, which is one of the first of the three phases in classical compiler theory, when now the program that handles the compilation actually takes all of the strings of your source text and then now create tokens that are meaningful to the language. And then it's going to look at the relationship among all of these strings of tokens by parsing them into an abstract syntax tree. And then usually is now generate code in that particular platform as a portable binary. Okay, again, JavaScript doesn't behave like that, but in this last phase, but it does at these first two phases. Okay, and also have some intrinsics because depending on the JavaScript engine, it has now the profiler and the compiler inside of the engine that actually makes some further optimization of the code before it is executed. In any case, going into that, what is relevant here is that when we talk about lexical, it means that it matters where the code was written. So also we saw a couple illustration of how now the scope works by using now bubbles, and the scope change as well by thinking that as like elevator, like a building, right? When you go from one floor to another one, looking now for an identifiers, and what are the phases that happened that describe these two phases in JavaScript: the compilation or the parsing, and then the execution, and how the scope managers play parts in each one of them. Okay, so then we explore now is the scope. All right, so for example with functions, with block scopes, also the imply parameter scope, why it is important for us to define is functions, using now name functions rather than arrow function, because they are not lexically available, right? And also it allows you to describe its functions. Okay, so it allows you to understand what this function does, and look at also at the global spaces, the global landscape, or the global scope, or the other scope, especially the global scope, where you can run is JavaScript, right? Whether it is on the browser, and you can use in window, and how now, for example, var and functions, keywords behave, as well as the let and cons, and the same for the service worker, how you can have access to the global object via the self, how now the common GS and ES6 model works. In the case of the common GS model, you can think of this like a function wrapping another function and injecting some dependencies on this scope. And also is the relationship, or why do we have scope at the end of the day, right? So when you need to share is functionality across different other scopes, you put them at that relevant place. And speaking of putting at that relevant space, that's why I look at the life cycle of the identifiers like var, or the variables like var, functions, let, and cons, how they behave normally. For example, like var and function, they host per function scope. Let and cons host per block scope. How now they behave in looping syntax, right? And also is this a specific observable behavior that let has when you define when you access to an identifier before declare that variable. So AKA it is the TDC, the temporal depth sum. So and now once we learn the ins and outs of lexical scope and working with functions and the global scope, right? We also raise our level of attention to decisions and patterns that we need to apply across our programs. Okay, so what does it mean is that to avoid some common gotchas, at least in the JavaScript development, like naming collisions, or to avoid naming collisions, unintended dependency, or unexpected behaviors. So we now wrap these variables and expose them to the outside world with the bare minimum. So we reduce the overexposure of variables to the outside world. Okay, so I do think this is part of the maturity that any tools or any industry have in that domain. Okay, so that is quite interesting. I also look at how can you now overexposing is your variables by using immediately invoked function expressions, or also is by wrapping is functions and expose is only the relevant properties that you want to, and also is for the let and block scope. So with the let and cons in the block scope. The question is that when you do that, it is up to you to decide. But the principle stand here is that let's going to reduce the overexposure of variables in a particular scope, right? If you find yourself to conditionally to conditionally check if a particular property exists or not, do not define functions in if block statement, you can enter into a wonky state. In fact, check that behavior before, and if that behavior is not guaranteed, well, now hold the functionality into a variables, and then you can now update that properly. So all of this is just to describe that high-level thinking that is needed based on the decision and patterns when it comes to develop this kind of application here on JavaScript. And then the other is this. Once we look now at the functions, which is part of this scope, all right, and if we inspect the anatomy of this function, we have two things here. We have closure and we have the value of this. But here what is relevant is on the closure. And the closure, the TLDR, is that any time that you, and this is also come from the functional programming, okay, this is part of the behavior of a mathematical field that study is functions known as Lambda Calculus. That is a mind-bending thing. You know, it's like Lambda Calculus. All right. So in mathematical logic, the Lambda Calculus is a formal system for expressing computations based on a function's abstractions and application using variables binding and substitutions. In other words, you are now able to describe is a computations or a set of instructions that are going to perform some computations and now hold the computations using variables binding and the substitutions, aka, which is exactly what we do here. So this is the functional programming here. So Alonzo Church in 1930, as part of his research into foundations of mathematics, which came with the logically consistent and document in 1940. So again, all of this, right now, what I'm doing here is just leveraging that is mind-bending, bro. That is mind-bending. So what I'm doing here is just leveraging is the R&D over the past almost 100 years ago. Holy shit. Oh my god. Fucking hell. 100 years ago. Oh my god, fucking hell. As part of his research into the foundation of mathematics. In 1936, Church found a formulation which was logically consistent and documented it in 1940. So we're talking about, so we don't miss this 80 years of R&D in this domain. So now we know what Lambda Calculus is, because we actually have seen that we can now in the language hold variables, hold functions as value, and held inside of this variables that is gonna be act as a containers where we can carry over this functionality across our program. That is a mind-bending stuff, bro. I don't know what they were smoking, bro. And I do what they were smoking is the Second World War in this moment in 1940, bro. So now this is what Lambda Calculus. So so because of this, all right, and now as I explore about is this behavior that functions has, or this this behavior that function has, which is known as closures, which is, hey, anytime that you need to keep track values outside of the function scope, inside of the functions, and that function is executed in a different scope change from the variable, right? This is when you create now a closure. This is when you now carry over is all of these external variables reference that you are using inside of this function, but executing in a different part of your program. That makes a lot of sense because with closures you can create now a couple things. You can now keep track of things along the time, right? So the observable behavior of closure is, hey, closures, you need to, so closures are exclusively for functions. If you want to create a closures, you now is referencing variables from the outer scope inside of that functions. You now create an instance of that functions. Exactly, you create an instance of that functions, and then you call that. Okay, so a function must be invoked. So you create a function. Also, because you can create closure exactly with closure is only exclusively for functions. So, so closure, you define a function in this, and then you so you define a function. You have at least one reference of a variable outside of the function scope. You invoke this function in a different part of the program where that variable is being used, right? So this is the observable behavior of function. This is the observable behavior of function. So because now this allows to keep track or to remember its variables over time. So not only that with functions or with closures, we can define some simple stuff like counters, all right? And we also have to remember that anytime that you define is a closure, you need to also find ways to clean that. So make that space in memory that is reserved by the language available to be garbage collected, to be swept out, right? Here. So this has an important impact on building efficient and performance programs. So closures can unexpectedly prevent garbage collector of a variable that you otherwise done with. So I also another question here rises that, hey, variables are per variable and per scope, or closures are per variable or per scope. So is per variables, not per scope, okay? Which is good. And then we look at an alternative perspective of this, that remember that those references that you're holding inside of these functions that live outside of the function scopes, they are now live link, all right? And why is this? Why we look at all of these things? You know, it's like, why closures? So why closures? Because with closures, that not only that it allows to hold some piece of information here privately, so nobody else can use it unless you want to define some methods to access to that data. Okay, so closures, right? So we explored two models for mentally tackling closures. Observational, which is closure is a function's instance. Remember, it is outer variables, and even as that function is passed to and invoked in other scope. And the implementation is that closure is a function, is a function instance and a scope preserved in place while any reference are passed around and invoked from other scope. So to summarize the benefit of a program, so closures can improve is the co-organization of our programs, all right? And also improve the readability and the co-organization of our programs, and also remember previous information instead of having to compute it each time. Two things are here. Two things are the key of the closures. So of why do we have closures, right? So closures allow us is to organize our codes for readability, okay, and also is to keep some information, right, over time instead of having to compute each time. Let me actually write it down here. Let me actually write it now. It is like the U. Deep JavaScript, I think it is. Is this? Oh my god, there you got it. Exactly. So for example, like this. Block and close club. Exactly. Illustrating using closures. So why do we have closures? Okay. Okay. Why do we have closures? So any time that you need to hold some information over time without recalculate it, okay, for any time you need to hold some information over time without recalculated, and the others to organize your code for readability, right? Improve code readability, bounding scope exposure by encapsulating variables inside of functions instance. Okay, you're gonna get technical. All right. So improve code organization, readability by holding variables. Okay, so bounding scope exposure. Okay, and bounding scope exposure. Bounding scope exposure. Okay, bounding scope exposure. Improve code organization, readability, and bounding scope exposure by holding those references. Okay, by encapsulating variables, by encapsulating variables reference inside functions instance. Okay. Inside function instance, while still making sure the information in those variables is accessible for future use. But it's this: improve code organization, readability, and bounding scope exposure by encapsulating variables reference inside functions instance. to be used at future point. Okay. While still making sure that information in those variables is accessible in the future. So improve co-organization, readability, and bounding scope exposure by encapsulating variables reference inside functions instance, while still preserving data of those variables to be used in the future. The result, narrower, more specialized functions instances are cleaner to interact with, since they preserve information and doesn't need to pass since they preserve information that doesn't need to be passed in every invocation. Exactly. So they preserve information that we don't need to pass on every invocation. That makes a lot of sense. Exactly. So now I do think that'll be all for this video. Yeah, that'll be all for this video. So take care. Bye bye.